Okay, and in chapter 7, something that we're going to have to do a lot of times is simplify radical expressions. Okay? We want to simplify the radicals rather than get a decimal approximation because we're looking for exact answers. All right, so this is something really important to this chapter, and it's really important to write triangles because Pythagorean theorem deals with squares and square roots. Pieces of special right triangles, 30, 60, 90, and 40, 40, 45, 45, 90 triangles have radical expressions in their lengths of their sides, so we're going to have to need to remember how to do that. So I'm just going to start by listing a bunch of squares, and you might want to copy these down sometime. I'm going to do it on the side board so that we have it. Y'all help me out. What's 1 squared?
1.
2 squared.
4.
3 squared.
9.
4 squared.
16.
5 squared.
25.
6 squared.
36.
7 squared.
49.
8 squared.
64.
9 squared.
81.
10 squared.
100.
11 squared.
121.
12 squared.
144.
I'm not done. 13 squared.
130.
No.
130.
164.
169. What's 14 squared?
196.
All right, now we're going. So where's 15 squared?
225.
16 squared.
256.
7. I think we need to have a squares test. 17 squared.
289.
I think we need to. 18 squared. 19 squared.
361.
20 squared.
100.
All right, I'm gonna skip around. 25 squared.
600.
30 squared.
900.
900. There we go. We'll stop there. All right. So there's a list of some squares. I'm going to actually underline those in red. When I find a red dry erase. I'm not seeing a red dry erase. I'll find one later. All right. I do have one. Because these are the numbers we're going to use as these squares when we're simplifying radicals. Okay? These are the only numbers we really care about. Are the squares. Yeah, you can take a picture when I get out of the way. Don't take a picture of me. All right. So we're going to use that list of squares to help us simplify radicals. So for example, I'm just making these examples up, so we're winging it today. Let's just do a real simple one. What if I say simplify radical 64? All right. So it is, the square root of 64 is a perfect square, so you just say that equals 8. You will not have a radical left over in your answer. It will just be plain old 8, okay? So if it's a perfect square, you do not have any radical leftovers. You just have that number, the square root of that number. All right? So what if we have something like radical 24? Then you would have to think of the largest square number that goes into 24. 4 is the largest square that goes into 24. So you break radical 24 into its factors. So we radical 4 times what? 6. So you change 24 into 4 times 6 because 4 is a perfect square. And what is the square root of 4? 2. So this simplifies to be 2 radical 6. So the square root gets pulled to the outside. The leftovers stay under the radical. We call that part the radicand. The stuff underneath the radical is called a radicand. The stuff on the outside is treated as a coefficient. Okay? All right. Let me think of another one. Radical 96. So is 96 a list in my list of squares that's on the board underlined in red? No. So I need to think of the largest square number that goes into 96. Is 16 going to 96? How many times? It's multiplication, darlings. Yeah, we're definitely having a square roots quiz. All right. So, 16 times what? Can y'all tell me that? 6. Okay, I agree. Now, what is the square root of 16? 4. So, this simplifies to be what? 4 radical 6. All right. What about radical 75? What's the largest square that goes into 75? 25 times what? So what does that produce to? 5 radical 3. Any questions? Alrighty. What about radical 700? What's the largest square that goes into 700? 25 goes into it, but is 25 the largest square that goes into 700? No, it's what? 100. 100 times what? 7. So what does that reduce to? And radical 7. Here's one that messes people up. Radical 72. And the reason it messes people up is because there's actually quite a few squares that goes into 72. Okay? So what we want to do is find the largest square that goes into 72. And to me, the best way to make sure you get the largest one is to work up your chart. So I have my list of squares over here. 72 falls between 81 and 64. So I'm just only looking at these numbers up here, and the first one I get to that goes into 72 will be my largest square. Okay? Does 64 go into 72? No. Does 49 go into 72? Does 36 go into 72? Yes. So that's my largest. Okay? I know 4 and 9 both go into it also, but you want to hit your largest. So that is 36, radical 36. And what's the square root of 36? 6 radical 2. So any questions about that? So that's just one that messes people up a lot. So just remember, if you are not sure and there's more than one square that goes into it, then work up your chart. Let's say that you didn't think about that. Let's say that the largest one you thought about was 9. So you said that radical 72 was radical 9 times 8, and you got 3 radical 8, right? Well, then you say, well, don't 4 go into 8? Right? So always check your radicals when you're finished and make sure there's not another square that goes into it. Because if that's the case, you can simplify some more. All right? So then you might notice, oh, well, 4 goes into 8. So I'm going to change that to 3 radical 4 times 2. And what's the square root of 4? 2 times 3 that's already on the outside. 6 radical 2. So I still got the same answer. It just took me one extra step. Does that make sense? So even if you don't think of the largest square right off the bat, double check your radicand and make sure it won't be simplified again. Does that make sense? It's just like when we're reducing fractions and we divide them by 2 to start with just because we can't think of anything but they both look even, so we do that. And then we see that they can reduce again. Okay? Same kind of concept. Okay? We simplify our radicals until they won't simplify anymore. All right. So let's look at some fancy stuff. Let's first talk about something simple like taking a square root of a fraction. Like, well, let's just do radical 25 over 49. Okay? If you take the square root of a whole entire fraction, that means the numerator and the denominator get their own radical. Okay? You separate the numerator and denominator and give them their own radical. And then you take the square roots. So what is square root of 25? Over what's the square root of 49?
7.
7. And then you make sure that fraction won't reduce any more than 5/7 will not. It's simplified. Okay? All right. Well, also with radicals, you cannot leave a radical in a denominator. Can't do it. So like say we have this, radical 5 over radical 2. Is there a square other than 1 that goes into 5? No. What about 2? No. So that will not simplify as far as radicals go anymore. Okay? However, you cannot leave a square root symbol in a denominator. So we learned in Algebra 1 something called rationalizing the denominator. Okay? And the way we rationalize the denominator is we take that denominator and put it over itself as a fraction. So we would multiply this by radical 2 over radical 2. What does anything divided by itself equal? 1. So this is the same thing as multiplying that fraction times 1. It just looks different. Okay? So mathematically, we're not really changing the value of it. We're just changing the way it looks. Okay? And then to multiply fractions, that we multiply straight across, left to right, numerators and denominators. And when you're multiplying radicals, you multiply insides with insides and outsides with outsides. And these are all insides. So radical 5 times radical 2 will be radical 10 over radical 2 times radical 2 is radical 4. Now, is there a square other than 1 that goes into 10? So radical 10 will be left radical 10. And it's okay to have a radical in a numerator by itself. And what's the square root of 4? 2. So now we just have a plain old number in the denominator. So that's how we rationalize denominators. You take the denominator, if it will not reduce as a radical and the radical go away, we multiply by the denominator over itself, multiply across, and simplify as you go. So let's practice a few more of those. I'm actually cheating. Let's do 12 over radical 5. 12 over radical 5. Now there is no radical in this numerator, but that's okay. Can we simplify radical 5? No. So we have to rationalize the denominator to get it out of there. Can't have a radical in the denominator. So that's what I'm going to do. Multiply by radical 5 over radical 5. All right. So then you multiply across. So 12 times radical 5, you got one term on the outside of the radical and one term on the inside of the radical. So you can't combine those. So you just basically, it's like saying 12 times x. 12 times x is 12x, right? So 12 times radical 5 is just 12 radical 5. Okay? And then radical 5 times radical 5 is radical 25. 12 radical 5 won't simplify, so you leave it 12 radical 5. Over the square root of 25 is 5. And then you look and see if your outsides will reduce. 12 over 5 will not simplify as a fraction, so that's your answer. Okay? So something about radicals to get used to is you don't have pretty little numbers. You just have a lovely little fraction with a radical in it, especially when you have to rationalize. All right, I'm going to give you guys one. Actually, I want to do one we have to simplify. Sorry, I changed my mind. Let's do radical 12 over radical 2. Why not? All right. So how are we going to get rid of the radical in the denominator? Multiply by the denominator over itself. Now, I know radical 12 simplifies because I know 4 goes into 12. But since I'm going to have to multiply by that anyway, might as well just leave it be until you're done multiplying. Okay? I mean, you could go ahead and simplify it. I've made students do that before. But since we're just multiplying and we're saving steps, we can just do that later. So what is radical 12 times radical 2? Radical 24 over denominator radical 4. And now does radical 24 reduce to what? Radical 4 times 6, which is 2 radical 6. And I did it above so I didn't have to write the whole fraction out again. And what's the square root of 4? Just plain 2. And you see how you have 2 divided by 2 right there? Well, that makes a 1, right? So the answer is just radical 6. So are there any questions on anything we've done so far with simplifying radicals? This is Algebra 1, Chapter 11. Okay, we did this at the end of Algebra 1. And I'm going to stop my recording for today. Have a good one.